Hello everyone, today we are going to study about device drivers. The study on device drivers is focused on the following aspects. First, what are the types of devices and the device drivers? How the devices get connected over the parallel or USB port. Third, how does the Linux supports device driver development. Fourth, how it makes the job of operating system and the end user simple. In the earlier topic on the device drivers, the issues related to usage of device drivers were discussed. In this topic, we are going to study the device drivers from the perspective of developers. A device driver can also be considered as a software layer between the application program and the hardware device. A device driver may be written in a manner that it is exclusively available to a single user at a time, or if the nature of the device permits sharing among different users, the device driver software has additional features to keep session of every user requesting the device. For example, a device like printer may be used exclusively by a single user or may be made available over a network, where other users can share the printer and get the prints one by one in a queue. The device driver in a second scenario is more complex than the first one. Also, it is difficult to test and debug a device driver which supports concurrent environment. A device driver developed for network interface card may have to deal with concurrent processes trying to send and receive the packets over the network. In this case too, the driver has to maintain session for each request made by a process. The incoming packets are asynchronous events. The packets must be collected, identified and dispatched before a process takes care of them. The system is in charge of delivering data packets across program and network interfaces, and it must control the execution of the programs according to their network activity. Accordingly, all the routing and the address resolution issues are implemented within the operating system. One of the good features of the Linux is its ability to extend at runtime the set of features offered by the operating system. This means you can add functionality to the operating system or remove any functionality while the system is up and running. Each piece of code that can be added to the operating system at runtime is called a module. The Linux operating system offers support for quite a few different types or classes of modules, including but not limited to device drivers. Each module is made of object code that can be dynamically linked to the running kernel by the insmod program, insert module program, and can be unlinked by the rm mode, that is remove module program. This is unlike Windows, which requires the restart of the operating system whenever change takes place in any part of the operating system. The dynamic loading also helps in real-time application, where a new driver replaces the old driver without restart or reloading the operating system. There are two basic types of devices available on any Unix system: the software devices such as RAM disk and hardware devices such as hard disk and printers. The software devices are driven by a software driver. Generally, a portion of the memory is referred to as software device, also called pseudo device, and driver ensures the exclusive write access and shared read access across different processes. The hardware devices are CD-ROMs, disk drives, tape drives, printers, scanners and terminals. The hardware devices are categorized as block devices, character devices, memory mapped devices or network devices. A block device is a mass storage device such as a disk that can access data, store it and return data to the processor in fixed length transfers. A block device driver uses the integrated page cache for all the data transfers. M-mapped or memory mapped device drivers are those in which the hardware is memory mapped into a user's address space. For example, if a memory location X is mapped to a hardware device, a data returned to a memory location X from the central processing unit is in turn returned to the hardware device, or a data read from the memory location X in turn comes from the hardware device. No interrupt or DMA service routine is available to the user process. Next, we discuss the various types of device drivers. The Linux operating system puts the device drivers under three categories: character device, and accordingly the device driver module is written in a manner which reads or writes one character at a time from or to the device. The module implementing character-wise read and write is called a character module. A character device is one that can be accessed as a stream of bytes like a file. A character driver is in charge of implementing this behavior. Such a driver usually implements at least the open, close, read and write system calls. The keyboard and the display on the screen in the old CRT monitors are the examples of character devices. Similarly, the block module performs the read or write operation in terms of block of data. The external devices operating on block mode have a processor and memory buffer to send receive the data block. For example, take example of a digital camera. It can work in offline mode for taking pictures. The pictures so grabbed are stored in the SD card in the compressed form and sometimes in the manufacturer's proprietary format. However, when the camera is connected to a desktop over a USB port, the application interface provides the access to the SD card and all the picture files are shown to the users. The user can then copy or delete the picture files in the camera and use the files for printing hard copy of the photos. The communication between camera and the desktop is accomplished by the device driver on the desktop aside and also the embedded software developed within the camera device. The next category of device is the network device. Networking interfaces are the third class of Linux devices. The role of the network interface is similar to that of a mounted block device. Both are required to register first with the operating system so that the packet transmission can take place from the computer system to the outside world and the outside world to the computer system without simple calls like read and write. However, the important difference between the network interface and the block driver is that the block devices receive and transmit information to the operating system only, whereas a network receives packets asynchronously from the outside world. The network driver also supports a number of administrative tasks such as setting addresses, modifying transmission parameters and monitor traffic along with maintaining error statistics. The network interface has to concurrently support multiple processes trying to send and receive data packets. Next, we talk about the connection of the device and the desktop through the connector ports. The device can be connected to a computer system only through the connector port. Earlier, the popular ports were serial and parallel ports. The slower devices were connected over a serial port and the faster devices were connected over a parallel port. In order to develop a device driver for devices connecting over a port, it is essential to understand the pin details of the port. Earlier, the printer device was connected to the desktop using parallel port. Therefore, the specification of the parallel port is taken up as an example here. The parallel interface as shown in the figure has 25 pins and is made up of 3 8-bit ports. The typical PC board configuration allocates an address 0x378 to the first port, that means a data value 19 hexadecimal written over the address will actually be returned to the I/O port 0x378. The write operation so performed will change the status of pin 2 through 9 of the parallel port as per the value 0001 1001, which stands for 19 in hexadecimal. The data port designated with address 0x378 is a bidirectional port and connects directly to pins 2 through 9 on the physical connector. The second port is read-only status register designated by the address 0x379. When the parallel port is used for connecting a printer device, the status register reports various aspects of the printer status, such as being online, out of paper or busy. The third port is an output-only control register which controls the asynchronous communication between high-speed desktop and low-speed printer through the interrupt control mechanism explained earlier. All the printer manufacturers providing the printer connection over the parallel port used to comply to this specification. These days, the USB port is a common standard for connecting most of the peripherals to the desktop. However, for learning purpose and develop initial understanding, the background of the parallel port helps. Next, we take up an example of a printer device connected over a USB port. It is essential that the printer device should provide a USB cable that complies to the USB specification and fits well with the USB port. Next, the operating system should know the pin details of the USB cable and accordingly facilitate or make available the mechanism of initializing, checking the device status, opening, reading and writing the device. Using the basic mechanism, a third party vendor manufacturing a specific type of printer knows what to write, in what format to write, how much to write, one character at a time or bulk data equal to the available buffer size in printer, when to send data, how the printer demands the data for print, at what rate the data to be sent. The above information is specific to the printer device and varies from one printer to another. Therefore, for communication with a device, it is required to write a program that effectively addresses the questions written above and establishes the connection between the printer device for printing purposes. In any software package like Microsoft Word, when we issue a print command, the typical options for the user to select are pages to print. That means user has to specify whether he wants to print all the pages or he wants to print only a current page or he wants to print the selected pages, say from page number 2 to page number 10. Secondly, he can also specify how many pages per sheet he wants, whether 1 page per sheet, 2 pages per sheet or 4 pages per sheet. Third, you can also specify the number of copies. You can also specify what type of document you want to print, where there are various types of document like size of the paper, A4, A5 and all. You can also specify fit to page option. It does the scaling and convert the printout as per the available page in the form of paper size like A4, A5, executive, letter or other variants of the page size. However, an interface providing this functionality is an application developed by the Windows Common Device Framework written over the device driver. Therefore, interface is identical irrespective of the type of the printer or the printer connection. There are other classes of the driver modules that are embedded within the system and provide connection for the various devices. For example, the ports and buses related to USB need special modules called Universal Serial Bus Module. Similarly, the SCSI bus interface requires special modules to handle the interface specification of SCSI. Every USB device is driven by a USB module that works with the USB subsystem. Next, we discuss the security issues related to the development of the device drivers. A device driver developer gets privileged access not only to the device for which the device driver is developed, also it gets access to the interrupts, the operating system memory area, and other important functions of the operating system. Any malfunction or unauthorized access can damage the operating system and the overall functionality of the computer system. As a device driver developer, you should be aware of the situations in which some of the device access can adversely affect the system as a whole and should provide adequate control. For example, the device operations that affect the global resources such as setting an interrupt line which could damage the hardware such as firmware definitions, or that could affect other users such as setting a default block size on a tape drive are usually only available to the privileged users. Accordingly, the device driver should consciously handle these issues so as to avoid any malfunctioning in the device. So, what we have learned today is the role of the device driver, the examples of the device driver for printer, camera and other devices, the details of the common Windows framework for printer devices was discussed, the functioning and the pin details of the parallel port for connecting to a device was discussed in short. Thank you.